We'll be having our last session today. We'll be having our last session today. And also, after today's session, I'll be giving you your final project, and I'll give you the guidelines and the processes of submitting the projects after today's class. So, but start, before I commence today's class, I promise that I will do a little recap of my last session. I'll do a little recap of my last session for those that were around. So that was what I said. So that is what I'll be starting with. For just 10 minutes, I'll be reviewing what we did, like what I did last, because I was not able to do this session because I was feeling ill. I was not feeling well like that. So I will start with the last session. For those that were around, what with my last session, that is session 4. For those that were around, what was session 4? For those that were around, answer me. No one.
Correlation and regression.
No. I know that that was the last session. I was not the one that took that class.
Oh,
So I
okay.
said my
No,
own last session. So you were not in class. Abdulhamid.
um, I'm not sure. What's the topic first? I can't remember.
You can't remember. Okay. Anyone else? I think I saw Daniela joined. She was the one that was even asking for recap that last thing. I saw her just now and she's not here again. So not to take our time, what we did last week was we treated normal distribution and we did introduction to inferential statistics. So we discussed Poisson distribution, binomial distribution, normal distribution. That was under under probability distribution. So under probability distribution, that is what we discussed. We discussed binomial, um, Poisson distribution, and normal distribution under probability distribution. So I'll be sharing my screen now so that you can see the last slide. So I'm already sharing my screen. So hope you can see my screen. Can you
Yes,
see
sir.
my
Yes,
screen?
sir. Yes, sir.
Okay, very good. So even I would just advise you that you should study the slide well and make some extra research on your own. So I'll be starting this one. We've treated it already. The normal distribution, we've treated it, and I said it's also called Gaussian distribution or bell-shaped curve. So it is for continuous data. Normal distribution is for continuous data, and these are the properties of normal distribution. The center of a normal distribution is the mean. So that is why I say it is centered at the mean. The total area under a normal distribution curve is 1. The total area under a normal distribution curve is 1. It is also symmetric about the mean. So these are the properties of normal distribution. So shifting one standard deviation is roughly 68.3. So this is the diagrammatic representation of properties number 4, 5, and 6. This is the representation for it. Properties 4, 5, and 6. So this is the diagrammatic representation for it. When you move one standard deviation to the left or to the right, it will take 68.3%. Like let's say approximately 68%. But if you move it twice, either to the left and to the right, it will take 95.5. If you move it three times, it will take 99.7. So this is diagrammatic and the division. So how it is separated, this is how it looks like. And Z score. So I told last class I mentioned that Z score is used for standardizing a normal distribution. The z-score is used for what? Standardizing a normal distribution. And the formula for a z-score is z is equals to the data points, that is the value, minus the mean over standard deviation. So you can see from here that z is equals to x minus mu over sigma, x minus mu over sigma. So that's the value for z score. So if we are standardizing any normal distribution giving a data point, that is an individual value. So we calculate an example here. So this is one of the example. The mean is 170 and x is 182 and our sigma is 8. So using the z score formula, x minus mu over sigma, so we have 1.5 as our z score for that data set. So that's that about that. So this is the application of normal distribution in data analysis. So this is how we can apply normal distribution to data analysis. So other common probability distribution, this one are discrete probability distribution. They are not for continuous data. They are from discrete random variable. So you have the binomial distribution and the Poisson distribution. So the binomial distribution is a distribution that describes the number of sources in a fixed number of independent trials of a binary experiment. Binary experiment means from the word binary. That means every trial has only two possible outcomes. Is either it happened or it did not happen. So for example now, a JAMB exam, it is either a student failed the exam or the student passed the exam. There is no any other outcome from it. It's either you fail or you pass. So if you want to calculate the probability of like exam success rate, JAMB exam success rate, so we can use binomial distribution for that. You can use what? Binomial distribution for that. So, and this is the formula for it. This is the formula for binomial distribution. It means n combination x. N is the number of trial, while x is the number of required success. P is the probability of success, while Q is the probability of failure. And you can get your Q as 1 minus P. That means 1 minus probability of success. So this is the formula: n combination x times p raised to power x times q raised to power n minus x. So to calculate any binomial distribution, you use this formula. This formula is very, very important. It's very, very what? Important to use. So this is an example that we treated. A coin is loaded in such a way that it lands with a head showing 70% of the time. If it is tossed 5 times, find the probability of getting 4 heads and at most 2 heads. Probability of what? Probability of getting 4 heads and at most 2 heads. So from the example, we can see that the probability of success is the 70%, and 70% is what? Is 0.7. P is equals to 0.7, and the n, which is our number of trial, is 5. It is tossed 5 times. They toss the coin 5 times. So they try it 5 times. N is equals to 5. So our x value, which is what we are getting, the probability of what we are getting, is for the first one, we are getting 4. So that means our x is 4. You just put your values, find your final answer, then solve. So that one is simple. And for questions like at most 2 heads, at most 2s. That means at most means that means the highest should be 2. Probability of getting highest of 2, you can get 0, you can get 1, you can get 2, but it cannot be greater than 2. It must not be more than 2. That means you find the probability of 0, you add it to the probability of getting 1, you also add it to the probability of getting 2. So this is what we did here. Probability of s less than equal to 2, that means the highest point should be 2. It must not pass 2. That is meaning of at most. That is meaning of at most 2. It must not pass 2. So it must not pass 2. We can have probability of getting 0, probability of getting 1, and probability of getting 2. So this is it. And I give this as an assignment. The completion is as an assignment. So if you see any data set that is like this, just know that the probability is a binomial distribution. It is a binomial probability distribution. The BI shows that it is binomial. The N is the number of trial, and our P is the probability of success. Our P is what? Probability of success. So mean is what? So the mean of the binomial distribution is NP. That means the number of trial times the probability of success. The number of trial times the probability of success. While the variance is what? NPQ. Number of trials times number of failure, probability of success times probability of failure. So and where our probability of failure is what? 1 minus P. So we can also move to what? Poisson distribution. You can also move to, you can go. So sorry for that. So let's move to Poisson distribution. So this is what Poisson distribution means. It is denoted with lambda. So and that lambda represents the mean and variance of a Poisson distribution. The lambda represents what? The mean and variance of a Poisson distribution. So for a Poisson distribution, this is the formula. Lambda raised to power x e raised to power minus lambda over s factorial. I told you that lambda is of a the mean of a Poisson distribution. Your s is the probability of the value that you want to find, and e is a constant, is the Euler's constant, that exponential constant, 2.718 stuff. So that is our e, simple. So this is one example. A call center receives an average of 5 calls per minute. What is the probability that they will receive exactly 3 calls in a given minute? Sorry. So from there, our average call is 5. That means our lambda, which is the mean, is 5. What is the probability that they will receive exactly 3 calls? So in that case, we should know that our x is what? 3. So we've gotten our lambda, we've gotten our x. From this formula now, we can now find the probability that when s is equals to 3. You get? So that is what Poisson distribution means. So let's move to differential statistics. So the first part we'll be discussing is population versus sample. That means the difference between population and differences between sample. So number one difference is, for population, the entire group of individual or items of interest. Sample is the subset of individual or items selected from the population. So just know that population is just like a universal set. In mathematics, there's something called universal set and subset. So for population versus sample, just know that population is such as the universal set, while sample is such as the subset of a population. That means a sample is taken from a population. For example, now, all students in a country, so that is a population. The population is every student in a country. So taking sample from it is that we are now selecting let's say 500 students from all the students. So it's like the sample. So for population they use parameters, and for sample use statistic. Parameter is like a data point, a value of a population. That means a member of a population is parameter, while a statistic is a member of a sample. So do you get what I'm saying? So statistical inference is a process of drawing conclusion about a population based on data collected from a sample of that population. So you've collected data, you've collected some data, and you make a conclusion on that data. For example, now, um, let's say for a student score, you've collected the student score, and you just conclude that these students in this class they don't know mathematics. So that is an statistical inference based on the data you collected, based on their scores. Their scores is the data you collected. So based on these scores, that is what you use to make an inference on the data set. So these are key concepts in statistical inference. So you have population versus sample. We've explained that: estimation, hypothesis testing, significance value, and the p-value. So this is hypothesis testing. So hypothesis is just like an educated guess. You just guess. For example, now you say all Nigerian girls like money. It is an hypothesis. So it is when you have proven it, you carry out an experiment on it, and you've seen the outcomes before you can say that this hypothesis is true. And we have two types of hypothesis. We have the null hypothesis and the alternative hypothesis. So the null hypothesis is the basic claim, your own basic guess. For example, now you said the mean age of students in a class is 20. That is your null hypothesis. That is your basic claim. That is your like your first guess. That is your first guess. So your alternative hypothesis might be the mean is not equal to 33. So that kind of alternative hypothesis is a two-stage test, because it does not tell us directly whether the mean is greater than 20 or less than 20. It just says it is not equal to 20. So it is either um greater than 20 or less than 20. So if the alternative hypothesis are greater than or equal sign, it is a one-tailed test. It is a one-tailed test. So this is what I meant. Mean is equal to 33. That is your null hypothesis. So alternative hypothesis telling us that mean is greater than 33. That is a one-tailed test. When mean is not equal to 33, that is a two-tailed test. So this is p-value and significance level. P-value and significance level. And you have type 1 and type 2 error. Type 1 error is when you incorrectly reject the null hypothesis when it is actually true. So your null hypothesis says that the mean age is 20, but it is true that the mean age is 20, and you maybe incorrectly or mistakenly you did something and you say no, the mean age is not 20, it is 19. So that means you are rejecting a null hypothesis that is true. That is a type 1 error. But when you fail to reject a null hypothesis that is actually false, for example, now someone kill someone kill, the null hypothesis is that the person did not kill. Actually it is false, he killed. And you are saying that the person did not kill. You are accepting the null hypothesis, but here you will not say accept, you say fail to reject. You are failing to reject the null hypothesis when it is actually false. So that is a type 2, error, and this is able to denote that able to like visualize it. So, and these are some examples on it. So that's all. So, do I have any question before I move to today's work? Do I have any question before I move to today's work? Anybody? If you don't have question, please tell me there is no question, so I can move on.
No question.
No question. So, anybody else? Ayobami.
No question. I don't have question.
Okay. So, thank you so much. So, I'll just move to what I have today. And after that, within 30 minutes, we should round up. I'll just explain your final project for you. So I'm coming. Let me find the slide. So I've already dropped the slide on our group, on the statistics group. So you can check it out and be following the teaching. So today we'll be discussing advanced inferential statistics. So the last one I just finished was the introduction to inferential statistics. So we'll now come up a bit to some inferential statistic concepts that is like not too advanced but somehow advanced. So now let's come with start with what confidence interval. Confidence intervals. So, what does a confidence interval mean? A confidence interval is a range of values that is derived from sample data used to estimate an unknown population parameter, such as a population mean or proportion. So, it provides a way of quantifying uncertainty about the estimate. So, a confidence interval, it is what tells us that this our data is estimated, and it is what us to prove it is what allows us to prove an uncertainty. Certainty means something that is not sure about our estimated value. So this is the explanation. When you make an estimate in statistics, whether it is a summary statistic or a test statistics, any one of the statistics, so there's always uncertainty around that estimate, because the number is based on a sample of the population you are studying. That means there is always uncertainty in whatever result or whatever outcome that you bring out, because you are not carrying out experiment on the total population. You are just choosing sample. You're just taking out sample from the population. So it is this confidence intervals that allows us to quantify this uncertainty. So the confidence interval is the range of values that you expect your estimate to fall between a certain percentage of the time. Expect your estimate to fall between a certain percentage of the time if you run your experiment again or resample the population in the same way. So the values you want to get if you carry out an experiment again is what you call confidence interval, and it is the percentage of times you expect to reproduce an estimate. So, and the confidence level, yes, the confidence level is the percentage of times you expect to reproduce an estimate between the boundaries of the confidence interval. So we have confidence interval and we have the confidence level. So the confidence level is denoted by the alpha symbol. So the confidence level is the probability that the confidence interval contains the true population parameter. So it is the confidence level that allows us to know the certainty about a population parameter, about the parameter of a population. So, for example, a 95% confidence level means that a 95% confidence level means that if we were to take 100 different samples and calculate the confidence interval for each, we would expect about 95 of those intervals to contain the true population parameter. So confidence level is just telling us how sure or how true our confidence interval is. You get? The confidence level is telling us how sure or how true our confidence level is. And to get our confidence level, it is 1 minus the alpha value. So if you have an alpha value of p less than 0.05 for the statistical significance, so our confidence level will be 1 minus alpha. Our alpha is 0.05. 1 minus 0.05 is 0.95, which is to percentage is 95%. So these are the common confidence level that you see is 90%, 95%, 99%. These are the common um confidence level. So let's move to t-test. I think after t-test, we'll move to ANOVA. Then I think we'll spend more time on that ANOVA because there is a long calculation there. There's a long calculation there. But let's just do this t-test and go to ANOVA. So a t-test is a statistical test that is used to compare the mean of two groups. Let me call it. A t-test is a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or a treatment actually has an effect on the population of interest or whether two groups are different from each other. So it is used to determine if two groups are significantly different from each other. So majorly when you use a t-test is when the size of your sample is small and follows and the data point follows a normal distribution. So and I told you a normal distribution is a distribution for continuous data. So t-test also calculates for continuous data. So there are three major types of tests that we have. We have the one sample test, the paired sample test, and the independent T sample test. Independent uh, independent sample test. So when do you use this test? So if the group comes from a single population, so if like from a single population, you are taking two groups, you took the two groups from a population, that means you performed a paired t-test, pairing from the same thing, but you take two different things from one thing. That is a paired t-test, and it's also called a within subject design. Because the groups that you take out, your samples are from a single population, not from two different populations. But if the groups come from two different populations, it is like two different species or two people from two separate cities, you perform a what? A two sample t test. A two sample t test, also known as independent state test. It is a between subject design. So note that word within subject design and between subject design. Within subject design is from a single population, while the between subject design is from two different population. So for example, now if there is a one group being compared against a standard value, one group that is compared against a standard value. For example, now you are comparing the acidity of a liquid to a neutral pH of 7. So the standard value is the pH. The pH is 7. You are now comparing the acidity of the liquid to that standard value, to the general value. So that kind of test is a one sample t-test. You have only one group and you have like a reference point that you are comparing the group to. Reference point that you are comparing the group with. So that is a one sample t-test. And this is just like a diagrammatic. So paired sample t-test investigates whether there's a difference within a group between 2 points in time. A group between 2 points in time. So this one, independent, as you can see, two different groups. You have two different criteria, two different origin, two different backgrounds. You are comparing it between, this one within. So now moving to the last one, which is the one sample t-test. So whether there is a difference between a group and a standard value, or whether a subgroup belongs to a population, and also use a one sample t-test to test whether a sample belongs to a population. So now let's move to the ANOVA part. Let's move to the ANOVA part. So ANOVA, the full meaning of ANOVA is the analysis of variance. So that is where you got the word ANOVA from. It is a statistical method that is used to compare the mean of three or more groups. That means it is from three. As you can see, the t-test is comparing two different groups. But this ANOVA now, it is comparing three groups. So when you have more than two groups, use an ANOVA test. So ANOVA works by analyzing the variance within groups and between groups. So there's a manual way of solving the ANOVA. So that's the example I put here. Though the solution is somehow long and you have to be following steps. You have to write the steps down somewhere to manually calculate or perform an ANOVA test manually. So, so let's go to one-way ANOVA. One-way ANOVA is a statistical test that is used to determine whether there are significant difference between the mean of three or more independent group. So you are comparing three different groups. So it helps in comparing what multiple groups to see if at least one group mean is different from the others, and it uses one independent variable. For example, now, and I think that's the example I put here. There is a teacher wants to test a teaching method, um the student performance based on different teaching methods. So use teaching method A and the student performance based on that teaching method A, teaching method B, and the performance based on that teaching method B, and something like that. So when do you use a one-way ANOVA? Use a one-way ANOVA when you have collected data about one categorical independent variable, one categorical independent variable, and one quantitative dependent variable. So the independent variable should have at least three levels. Yes, you should have at least three different groups. The dependent variable is one. It is depending on these three independent variables. For example, now the student performance is depending on these three different teaching methods. So the ANOVA, what ANOVA is telling us is that it's telling us if the dependent variable changes according to the level of independent variable. For example, now let's say our independent variable is social media use, and you assign groups to low, medium, and high levels of social media. So that is the levels of the independent variable. So you have to find out from this group the difference in hours of sleep per night. People in low level, how many hours a day is to sleep? put in medium level. How many hours a day? You have performed experiment on this, yes, and you want to carry out an experiment. You want to know your outcome. Another example is a brand of soda, and you collect data on Coke, Pepsi, Fanta, and to find out if there's a difference in price. So the difference in price is your quantitative variable. That is your independent variable. Why your independent variable is the Pepsi, the data you collected on the brands of soda. Another one is type of fertilizer and how you treat the crop with mixtures one, mixture two, mixture three. To find out if there is a difference in crop yield. The dependent variable here is the difference in crop yield. While the independent variable is the type of fertilizer, which is furtherly divided to three levels, like mixture one, mixture two, mixture three. So, for a null hypothesis of ANOVA, that means the basic claim of an ANOVA is that we are saying that there is no difference among group means. That is what our guess is. We just guess that all these groups are the same thing. There is no difference. So it is this test that will make us to carry out our alternative hypothesis. That means what we are wanting to result in, so that at least one group differs significantly from the overall mean. That is just what we want to make sure of, whether our null hypothesis is true or false. But if you are comparing only two groups, you are advised to use a t-test instead. So how do you interpret an ANOVA result? So is it to check if there is a significant difference between the average means of three or more groups. So I've said this before. For example, now if you are testing different teaching methods, ANOVA tells you if students performs differently based on the method used. So the key concepts to use, the key terms to use, number one, F value. So a number that tells us how much the group mean differ from each other is the what? Is the F value. And the higher the F value, the higher usually suggests that the group mean are different. A higher F value usually suggests that the group means are more different. So the P value is telling us the difference between the groups, whether the groups are statistically important or just due to random chance. So if our P value is less than 0.05, then you can say that the groups are different significantly. But if it is greater than 0.05, then we can say that there is no like there's little or no difference between these groups. So we'll be doing an example to tell us so that we'll see it with our eyes. So how to read ANOVA results. So the ANOVA results are usually shown like this. F is equal to 336 is equal to 5.89. So the numbers in the bracket are the degree of freedom. And there's a way you calculate the degree of freedom. So this is it. The p-value is 0.002 is less than 0.05. So that means there's a significant difference between the group mean. The F value 5.89, that is the F value, shows how much variation there is between the group mean compared to variation within the group. So we solve one question on F value and all those stuff, how to find them, and the example. So the 3 and 36 in the bracket is the degree of freedom. The first one is the degree of freedom between the group. Between the group. That means the total number of group minus 1. For example, now, let's say we have 4 different types of group. That means the degree of freedom is 3 for that degree of freedom between the group. So the degree of freedom within the group will now calculate the total number of data. Let's say our total number of data is 40. So and our number of groups generally is 4. So 40 minus 4 is equals to what? 36. So if our p-value is significant, p is less than 0.05, you might need to do further test called post-HOC test to figure out which specific groups are different from each other. So the exercise you are meant to solve. So this is the main example, and this is where we are stopping the class for today after explaining this exercise. So imagine you are a teacher who wants to test whether three different teaching methods, A, teaching method B, and teaching method C, affect student score differently. So you decide to conduct an experiment with the following result from a test score out of 100. So group A, that is the teaching method A. These are the scores. This is the results. Teaching method B, these are the results. Teaching method C, these are the results. So as I said earlier, there is this solution manually. It is cumbersome, but there is a software of finding an over test, but that one is not in the scope of this lesson. So the first method is to calculate the mean of each group. The mean of what? Each group. For group A now, we add 85 plus 78 plus 92 plus 88 plus 76. We know how to calculate mean. So we calculate the mean of each group differently. Then we calculate the overall mean. That means add all the data sets together. That means you add what? All the data sets together divided by the number of data that you have there. Here we have 15 data. So we add everything together. The overall mean, I'm sorry for the background noise. So the overall mean here is 85.27. So the step 3 is in your slide. You can just study the slide, and it is very, very well explanatory. It's very, very well explanatory. So I'll just have to explain some little things in this place. So the another thing is sum of squares between groups. So there are some things that you'll be seeing that is very similar, that is common here. So between groups and what? Within groups. Between groups, within groups. So between groups means like in a group, like group A, between group A, within, that means you are comparing everything together. So for sum of square between groups, so we calculate for A, you calculate for mean A minus overall mean all squared. That is n multiplying mean A minus overall mean all squared plus mean B minus overall mean all squared plus mean C minus overall mean all squared. So our n is 5. Yes, our n is 5. That is the number of data in each group is 5. So calculating it, summing everything, we have sum of squares between group is 64.5. So sum of squares within the group. So within the group is so sorry. Let me start. Sum of squares within the group. That means the result of each group, you are comparing it with the result of the overall result. So for A now, within the group for A, you are comparing it. You know that the overall result here is 85.27 minus 83.8. Okay, within the group, so sorry. So this between the group is for comparing each result for each group with the overall result. but within the group is for the each group separately. So you calculate for A, you calculate for B. That means each data point in group A minus the overall mean, you square it, you add it together. For example, like you are just calculating variance, as if you are calculating variance. So each point minus the mean all squared plus the next point minus the mean all squared. You do it for A, you do it for B, and you also do it for C. So and you combine all the SSW values together. That is sum of squares within the groups. So just note that sum of squares between and sum of squares within. So the next step is what? You calculate the degree of freedom. So the degree of freedom between groups is, here you have three groups, so you subtract one from it, that is two. Within groups, so you have 15 data points here. Within three groups, so 15 minus 3 is what? 12. That is the degree of freedom between groups, the degree of freedom within groups. So the next step is to calculate the mean squares. You have to calculate what? The mean square between group. That means the sum of square between the groups over the sum of squares between the degree of freedom between. So just note that everywhere you have B comes together, everywhere you have W comes together, and B means between, W means within. So the last value is your F statistics. Your F statistics is mean square between divided by mean square within. So for this data set now, our F statistics is what? 1.007. So now we have the F statistics. So we now compare this value with a critical F value. So there is a F distribution table that we can compare it from. So we compare it from the F distribution table, checking when the degree of freedom between group is 2, when and degree of freedom within group is what? Is 12. At the choosing significance level, commonly the significance level is commonly 0.05. So if this F statistics is less than the result you get from your F table, your F distribution table, then you fail to reject the null hypothesis. That means you are accepting that what you say, there is no difference between them, between the groups. But if it is greater than this F statistics, that means at least one group, at least there's one that is different from other groups. So you get what I'm saying. So and this is the assignment. Just follow the example I did here and use it to calculate solve this assignment. So before I show you your project, any question concerning this? Any question concerning this, please? If you don't have question, just tell me I don't have question, so I can move on.
Uh,
Eh?
no question, sir. No question.
No question from your side. What of
But
other?
I'll try and practice because it looks like I can do it. Yeah, that's what I'm trying to say.
Okay, okay. Just practice. There's a question in the assignment. Just practice with it. Practice
Okay.
with the assignment question, and you
Oh,
submit.
okay. Okay.
So hope everyone are online on WhatsApp.
Yes, sir.
Okay, I will drop the project questions now, and you go through it and ask questions that you want. You go through it and ask questions. I'll drop